Hi everyone and welcome to this tutorial on exponential smoothing in SAS EG. We should always start our session in SAS EG with assigning a library. A library is pretty much a reference to a folder on your computer where you can either find the files, and SAS can retrieve files that you have in its native format, in SAS format. Or it's also a place where SAS will record files, permanent files that you are creating in the process of your work. This is pretty much this folder where SAS will be recording or also accessing data that you already have there. So it consists of three parts. One is libname. You just really have to type libname, the assignment statement. After that, you will have to type the nickname or the name of your folder, of your library, and also you have to indicate the path in parentheses or quotation marks, and finish it all with a semicolon, and then you will have to run selection. So if you do not know where actually you can create a program, you just have to use this icon over there and you choose program, and it will open a new program for you. So this is how it works. And you can also check after that the log, and you can see that the libref BST477 was successfully assigned. That's all we need to know. So this is done. Now let's come to our data. So we have this data. This is called Amtrak data, and it has two variables. One is month, one is ridership. And here what we have actually, we have rides taken by passengers of Amtrak trains on a monthly basis, and the numbers are actually represented in thousands. So you have to multiply it by 1,000 to get the real number, and the data points are aggregated by month, beginning with January 1991 and ending with March 2004. So this is all we have. And again, for data analysis, when you want to forecast something, you cannot just use the original data set and run your forecast and decide, oh, I like this model, it has a low error. You have to split your data into a few parts, and I talked about it as well as I talked about how to import the data into SAS EG in the tutorial called naive forecasting, simple naive forecasting. So if you want to know how to do this, you can actually watch that video, that tutorial at the beginning, and you will know how to do this. In short, you have to prepare your time series data. It's all described there. After that, you have to actually filter the data and split it into two parts by creating two separate data sets. So if I click here, you will see that we have the data points beginning in January 1991 and they end in March 2001. So this is our training data set, and we kept 3 years that we can find here. 3 years of 36 observations to be our validation data set. So the goal is for us to train the model on the training portion of the data, and then to forecast the validation portion of the data. So let me just open right away here. If you create that library and if you have the file in this in a folder, that you referred to in your libname statement, you can also exit from here. So servers, local, libraries, BST477, and you can find your file here. So you will go to Analyze, Time Series, and Basic Forecasting. And you only need a few variables here. One will be ridership, forecast variable, and the time ID variable, the date, and that's it. So this is what you need to assign. And now let's go to forecast options. So here I actually have a lot of options, but let's do some housekeeping things. So let's start with this thing on the left. We actually have monthly data, so we can choose just right away monthly data, so we do not need to indicate anything else. SAS will do it for us. And now let me show you what models we have. We have exponential smoothing, Winters, multiplicative, and Winters additive method. So we can start stepwise autoregressive as well, but we are going to do just these three. Okay, so exponential smoothing. We have a few options, and by the way, this is how many points into the future we would like to forecast. If you remember, our validation was 36 observations, and that's exactly what we are going to forecast. So quadratic, we have a few trends. So this part is for the trend, and it's the same actually for any of these models, right? So you actually can choose any of these, right? Exponential smoothing, let's say we have a constant trend. The confidence level tells you what are the confidence intervals that you would like your forecasts to have. And in this case, we are going to speak about 95%. And you can also assign the value of alpha, and it can be, for example, 0.2. And that's pretty much what you need to do. After that, you also need to go to the plots, and for example, if you want to show actual values, you can click here. You can also ask for the residuals, and as well as you can go here and you can ask SAS to actually save forecasts for you in a file. If you want them to be saved permanently, then you will create, then you will go to the BSTA 477 library, servers, local, BSTA 477, and here you will store your, let's say, exp smoothing 0.2, so that we know that our alpha was 0.2, and you will say save, so that's where it's going to be saved. You can also choose parameter estimates and ask for the accuracy, R-squared type forecast accuracy. These will be the errors calculated for your training data. You can also change other things if you want to, and by the way, in the results, yes, so you can ask to save parameter estimates, and again, you can also change the library to BSTA 477 if you like. You can also ask to print this information for you. I don't want it to get printed because it can actually be a little bit too much. Also, we can ask for tail forecast accuracy, and you're going to see what it does. So let's go. This is our exponential smoothing. We see this graph. This is what we have. The actual data is represented by this dashed line, and the forecast is represented by the blue line, and you can see the confidence interval as well as the forecasted value, and it's actually the same. For smoothing models, it's typically the same, apart from seasonal models. So this is what we have. This is the residual plot that shows to us that sometimes we actually really miss it. Sometimes we are actually very close to the actual values, like here, for example, you know, we are not too far. So this is the graphs, and you can see, right, that when we use 0.2, yes, it's true, we do seem to capture this data structure a little bit, but not really perfectly, because we miss it a big time. So these are the two data sets that you can see created. They typically have 3 values per each date: the actual data, the forecasted data point, and also the residual, right? The difference between the actual and the forecast. So that's what you have. And also we have parameter estimates over here, and you can see a lot of different information, like, you know, how many values we had, and the other things, yeah, the weight, 0.2 for example, and also you can see the errors calculated, you know, like MSC, RMSC, MAPE, MPE, MAE, and all of these things that you can check. What is important here is that what is important for you to know is that all this information only refers to the training set, right? If you want to see the validation set, you will have to calculate those values by yourself. So this is what we have for the training portion. If we keep scrolling down, you will actually see our forecast for the rest of the data. And again, we do not have, you know, now the actual points. And you can see that it's always the same number for the forecast, right? Always the same number. It's only one number pretty much. And you have your confidence intervals, you have your standard deviation, so you have all of this, and they're all the same all the time. And that's our smoothing with the weight alpha 0.2. So this is what you have. If you want to calculate your values, your errors for the validation set, you can export this data. You can go here, export, and the data set has to be open. Export forecast to BSTA, blah blah blah, and you can just save it either as your Excel file or as a CSV file, and you'll be fine, you know. And then you can merge it with the existing file that you have with the mtrack data. Especially, I'm talking about the validation portion of it, right? You can use the forecasted values. I'm just going to open it. Yeah, so you can use the forecasted values for the validation portion of the data, and they start, I think, in April 2001. So you can add here the information, the missing information, and then you can calculate the residuals and calculate the errors right in Excel. Or you can do what we did before. You know, you can calculate errors applying the same method. It's just you need to know the data set names. And you can find them here if you click on modify task. If you don't remember what you called your data set and where it's located, you can just go to results and you can see. So if it says BSTA 477, so this is where you should be looking for the information, and these are your forecasts. So that's actually the file you should be referring to when you're calculating errors. But if I were you, I would just export it into an Excel format or CSV format, and then I would add it. I would add actually the forecasted values to the original data, and then I would calculate all the errors there. So this is about exponential smoothing. Now let's go and let's maybe, you know what, let's go to analyze again. And again, this is the training portion of the data. Time series, basic forecasting. And again, ridership, forecast options. We can also run another exponential smoothing model, and we can apply here 36. Now let's do, for example, again constant, but let's use the alpha parameter to be equal to 0.5, because there are some changes in the data, you know, some turning points. And let's set the time interval between observations to monthly. And again, the same, we want to see the plots because they show us a lot. The results, okay, let's save them just to work, and that's pretty much it. We can also ask for the parameter estimates, and we can ask for all these values here, and let's go. So these are the actual values. You can see now that we are much closer by assigning actually more weight to the most recent observations. We are much closer to the actual forecast. And you can also see here, I mean, it's still not a perfect residual plot, but you know, we see that it's a little bit less spiky compared to what we had before. Also here, you know, it would be a good idea to rename. You can say here, for example, exp smooth, let's say 0.2, and here we can say exp smooth 0.5. That's gonna be easier and better. So now what we can do, because we are lazy, we can just click here on modify task, and we'll have everything kept here, forecast options, and instead of doing exponential smoothing, we're going to do Winter's multiplicative method. I really don't know if this is multiplicative or additive trend present here. We will assume, for example, that we have to explore both. And you have actually a chance to see here something interesting. So they call it Winters, but maybe you know that Winters takes into account everything, right? The level, the trend, and the seasonality. And exponential smoothing is just the level. Then you have also the Holts model that takes the level and the trend into account, and then you have the full model that also takes seasonality into account, and that's called winters. So if you only need to run, let's say, the Holts model, then you only will have to specify the trend here, the weight for the trend. Okay, so linear, let's say constant is here 0.2. I mean, this is random, and this is like what SAS offered us, so let's go with this. We're not going to set anything for seasonal. We will just do Holts. Okay, and again we have monthly data, number of intervals, 1 month, and that's pretty much all we have. Again, you can play here, you know, with these like constant, linear, quadratic. Again, plots, perfect, results, great. And remember what is very important: when you run, say no. Because if you say yes, you're going to overwrite your exponential smoothing model. But if you say no, you're going to create a new one. And let me just right away rename it. So I will say Holts. And let's see. So wow, I mean, this is pretty close actually to the actual data that we have in the training data, right? And again, if you look here, you have your forecasts and everything, plus you also have down there, you will have all of your forecasts, and yeah, so that's what you will have. And because now we have the trend in the equation, now we actually see that our forecast values are different for each observation. And again, you can export it like I showed you before. Export this file, export this data set, and just change here the extension to Excel or CSV, and then use it to add the forecasted values for the validation data, and calculate errors, and you'll be good, because you will actually have the errors here for the for this training data set, right? MSC, RMSC, and so on. So you have all of them here, which is great. You're all set. Now let's click again. Let's go up. Let's find this Holts. And now we're going also to use winters. Again, I'm going to click Modify Task. Again, everything is set here. Forecast options. Instead of winters multiplicative, I can actually keep it, doesn't matter. I could also, by the way, check out the additive. So let's check it before we do anything else. It's all gonna be the same. Let's say run, and let's say no again, so that we do not have any problems here. And again, my goal here is not to create a perfect forecast, it's just to show you how to use SAS EG to run the forecasts you want to run. Okay, that's all I'm trying to show you. And again, we see that even additive works similarly perfectly. So this is great. And actually it works much better, because before the amplitude was much higher. For the multiplicative, we saw that some of the residuals were between 300 and minus 400 or something. Right now it's between 200 and minus 200. So the additive model seems to be better. I mean, we definitely need to calculate also errors for the validation data. So let me just add here that this is multiplicative. And this one is additive. Okay, so now let's modify task. And now we are going to run winters, but the regular winters. Let's go for the multiplicative first. Again, we can keep everything at linear, and you can decide. So we're going to keep everything at default. If you know, sometimes you can find some macros that help you to calculate the parameters for the alpha, beta, and gamma, and you can decide. So this is your alpha, this is your beta, this is your gamma, and you can decide it by yourself. what to do. So we can keep the plots, also the results, everything is gonna be the same. Okay, so yes, let's run, and let's again say no, because this is Winter's model that we are running right now, and we don't want it to overwrite the models we created before. So let's see if it's better or not. Again, the amplitude is the same, but now you can see that the residuals are not spread as much. This is definitely a better model than what we had before. But actually, let me just run here, right here, Winters, and it was a multiplicative. Okay, so what we could have done, we could have gone here, and we could have said that the seasonal cycle actually is, let's say, maybe every 3 months. Let's try. And again, we'll say no, because before we said that every month the cycle is over. Maybe it will be even better. Not really. Doesn't seem to be any better. Let's go back, let's modify, and now I'm going to overwrite it because this one is not better. Let's say every 6 months. Yes, now I want actually to overwrite it. Maybe every 6 months is going to be a little bit better, but we'll see. Again, not really. The amplitude increases, so maybe if you just do it on a monthly basis, maybe that's better. The last thing, let's try, let's say 2 months. And again, I'm going to overwrite it because these previous models were not good, so it makes no sense to keep them. Let's see. Okay, this one seems to be a little bit better, but again, we observe a huge magnitude, so that's why, you know, it makes no sense to use it. Thus, we'll go back to 1 month, and now let's use Winters, but now additive method. Again, 1 month seasonal cycle, and the parameters will be held at the same level. Again, you can play with these different values. It's up to you, and the plots, everything. And I'm going to override it. So let me just say yes. If you don't want to override it, you say no. If you want to override the information or the model that you created, then you will say yes. Oh wow, it's not that bad. And again, our residuals seem to be not so widely spread as before, which is perfect. But it seems that the multiplicative with seasonality was way better. So let me just do it here. Let me just say here add. And also what we could have done, we could have just used all of the default values suggested by SAS. So let's, I don't know if they are always the same or not, but let's try, and let's say run and no. So that we don't save actually, we save the model separately. No, not really, not perfect, but yes, it's not bad, you know, it's not really bad. Let me see. Okay, so this one is the previous one. Okay, great. So now let's, so this one is, we can just say modify task and we will see which one it is. Forecast options, this is not the default one, and this one is default. So we will say Winters additive. Okay, so this is Winters additive and this is default. Def. Okay. And let's also try doing the same, but now for multiplicative. And let's use 01557, run, no. Okay. And let's see what we have. And again, it's not perfect, and the amplitude of the residuals is increasing. So again, that's not, it's not the best model, so we can just actually delete it. We don't need it. And that's what we have so far. We created a few models. Again, when you create your model, you can just go to the output data after you have run it, and you can export the data that you have. You can also explore the residuals and errors for the training data, and for the validation you will have to calculate them by hand, unfortunately. For that you will need to export this data, and after that add it to your original data set, to the validation portion of it, and then you will have to calculate the residuals and the errors by yourself, on your own, in Excel. And that's it. That's how you run smoothing models.